achievements in the field of mathematics. We are now in the second quarter of our 10th grade journey. Previously on our channel, you have learned about circles and their parts, arcs, and central angles. But for today's episode, it is time to level up our knowledge as we proceed to theorems on secants, tangents, segments, and sectors of a circle. Of course, it is with great pleasure to give credit to the Department of Education in the Cordillera Administrative Region for providing Filipino learners with quality, convenient, and accessible mathematics modules that we are using as the basis for our video lessons. At this juncture, let us prove the theorems that we used in the previous module. Let us start with the following concepts.
A common tangent is a line or segment or ray that is tangent to two circles in the same plane. Common eternal tangents intersect the segment joining the centers of the two circles. Example, in figure 6, C and D are both common eternal tangents of central angle D and central angle E. Notice that they intersect the line connecting the center of central angle D and central angle E. Theorems on angles formed by tangents and secants. Common external tangents are lines, or rays, or segments that do not intersect the segment joining the centers of the two circles. Example, in figure 7, T and S are common external tangents. Note that they do not intersect the line connecting the centers of central angle M and central angle N.
Postulate on tangent line. At a given point on a circle, one and only one line can be drawn that is tangent to the circle. To illustrate, consider the central angle R in the figure 9. If C is a point on the circle, then the chord AB is the only one line that can be drawn through C that is tangent to the central angle R.
Now we will discuss about the theorems on tangent line. The tangent one is if two segments from the same exterior point are tangent to a circle, then the two segments are congruent. Tangent 2 is if a line is perpendicular to the radius of a circle at its endpoint on the circle, then the line is tangent to the circle. Tangent 3 is if two segments from the same exterior point are tangent to a circle, then the two segments are congruent. Theorems on angles formed by tangents and secants. Number 1. If two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Number 2. If two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Number 3. If a secant and a tangent intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Number 4. If two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the difference sum of the measures of the arcs intercepted by the angle and its vertical angle. In figure 16, chords WS and RX are two secants intersecting inside the circle. WR and XS are the two intercepted arcs of angle 1, while XW and RS are the two intercepted arcs of angle 2. The theorem states that measurement of angle 1 equals to 1/2 multiplied to the measurement of arc WR plus measurement of arc XS. Number 5. If a secant and a tangent intersect at the point of tangent C, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Theorems on secant segments, tangent segments, and external segments. Number 1. If two secant segments are drawn to a circle from an exterior point, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment. Number 2. If a tangent segment and secant segment are drawn to a circle from an exterior point, then the square of the length of the tangent segment is equal to the product of the lengths of the secant segment and its external secant segment. Number 3. If two secant lines intersect inside the circle, the product of the lengths of segments formed inside the circle are equal. To give this a proof, here's a table that will serve as your guide.
Great job, students! You made it until the end of our lesson. If you enjoyed our videos, don't forget to like, share, and subscribe to our YouTube account. Once again, this is your master, Shekinah Grace, ready to assist you in unraveling mysteries of numbers, equations, and mathematical concepts. Until next time.